order up to model, maximizing expected profit. In the previous video lectures, we saw that we can set order up to level such that we achieve a certain service level, for example, in stock probability. We can also try to maximize profit and set order up to level such that the profit is maximized. But for that, we need some kind of measures that will help us determine the overage and underage costs, similar to the news vendor model. Let's assume P is a retail price, and let's assume the gross margin for the product is 75%, which means 75% of the retail price is profit, and only 25% is the cost of the product, of procuring the product. Let's also assume the annual holding cost rate is 35% of the cost of the item. And let's assume there are 260 working days per year. So we can calculate holding cost. First, we take the cost of the unit, which is 25%, right? 1 minus margin times price, 25% of the price. Multiply this by the holding cost rate of 35%. That will give us the holding cost per unit per year. But remember, we need a holding cost per unit per day, because when we have too many units, we hold each unit till the next period, which is till the next day. So we just hold it for 1 day, and we have to have a holding cost for 1 unit for 1 day. So that's why we divide it here by 260. So we get a value, which of course depends on the price, a tiny fraction of the price. And remember, as before, always keep at least 3 digits starting from the first non-zero digit in order to have accurate number. Now, what would be, this is the holding cost, this is the cost of overage. If I have too many units, then I'm holding them, and then I'm paying the holding cost for each of those units for holding them for 1 day. What would be the penalty of having a back order? Well, we can assume that the penalty is just that Susan maybe will lose the gross margin, so 75% of the price, the profit, she will basically not collect it. This may be overestimation or underestimation. It could be overestimation because maybe the hospital will be willing to wait a day, delay an operation for 1 day, and maybe Susan has to give them just a smaller discount, like 20% discount or 50% discount, and she will not lose the 75%. Or on the other hand, maybe she will actually lose the sale completely, and maybe she might lose future sales because the hospital will be dissatisfied with her service and might shift to another supplier of pacemakers. Right? But let's not discuss this too much. Let's just assume this is a reasonable assumption of lost gross margin or lost profit. So then the underage would be, right, cost of having 1 unit too few in the inventory will be this value B, this gross margin that we lose. So now we can set in stock probability to the critical ratio, as in the news vendor model. We can set it to the cost of underage divided by cost of overage plus underage. And so if underage is B and overage is H, it gives me B divided by H plus B. And then plugging in the values that I calculated for the holding cost and the back order cost, we can actually find out that all the values depend on price P. And so price P can be removed from this fraction, right? I can divide the numerator and the denominator by P, and I will be left with numbers that are independent on the price. So I actually get a critical ratio of 0.9996. That's 99.96%, a very high critical ratio, a very high in-stock probability, right? And notice we did this without assuming what the price is. If the price is $100 or $10,000, the same critical ratio and the same in-stock probability is achieved. So this is actually a very high in-stock probability. And if you repeated this calculation for different gross margins, we assume 75% and we achieve this 99.96% in stock probability. But even if you assume something like 12% in stock, 12% gross margin, you will still get 99% in stock probability. So even products with much smaller gross margin might have a very high in stock probability, and so it is actually justified to assume very high in stock probability when you're trying to maximize profits. If you consider the case of the distribution center and trying to maximize the profit there, it's actually harder to evaluate because there are some parameters that are hard to evaluate. In particular, well, if you think about the holding cost, opportunity cost of capital is probably similar in the distribution center as it is in the territory. However, there are other holding costs that might be actually lower in the distribution center because this is a large warehouse that might have a lot of economies of scale. And so holding costs in the distribution center might be lower, maybe a little bit lower than in the territory. However, backorder costs should also be lower in the distribution center. Why? Because in the territory, if you have a shortage, then that means the hospital, your client, is directly affected, and you might experience, for example, the lost margin, profit margin, right? However, if you have a shortage at the DC, then the only immediately dissatisfied customer is one of the territories that will not get the unit that it ordered from the distribution center, right? So there will be just a delay of delivering to the territory. That doesn't mean that the end customer will experience a shortage because the two things would have to coincide. The DC has stock out, and that indirectly also causes a stock out and shortage of unsatisfied demand in the territory, right? So on average, the cost of back order might also be lower at the distribution center. But in any case, still a very high in-stock probability is necessary, although it might be lower than in the territory. It will still be quite high. And the final comment is that evaluation for the distribution center is probably quite complex, and we could do it via something like a Monte Carlo simulation in Excel.